On a February morning in 1997, work was about to begin on a major new flooring project. The task would involve laying nearly 50,000 square meters of plastic membrane and steel reinforcement, and the pouring, screeding, and finishing of nearly 8,000 cubic meters of concrete. The objective? To complete the project in just 8 weeks. The location for this ambitious project was the new car assembly building being built at Toyota's prestigious plant in Derby by Japanese construction giants Takanaka UK.
Takanaka and Toyota have a worldwide relationship. They're both from similar areas in Japan, and indeed Takanaka built the engine plant that supplies engines to this site. The plant is assembly building number 2, which means that it's a facility to be able to build the Toyota Corolla model in the UK. So of course that's a major development program for Toyota. I think it's sort of £250 million, of which the building costs are going to be in the order of £20 million.
With their vast knowledge of Toyota's operational needs, Takanaka knew that the flooring system they chose for this project had to meet a number of criteria.
When we were tendering for this project, we took a very fundamental decision about the floor, because with Takanaka's experience with Toyota worldwide and with the visits that we've had to this project and talking to Toyota during the tender phase, we knew how important the floor was. So the fundamental decision was that we were going to leave it as late as possible to make sure that it complied with their high specification requirements in terms of flatness and a really good finish. A feature there as well is not just its flatness, but it must be an anti-dust floor, because obviously dust doesn't go with making new cars. So at that stage we decided to leave the floor, as I say, as late as possible, and therefore it was important that we picked a system that would give us high-speed production. And we always looked in the region of laying something like nearly 500,000 square feet of concrete flooring in about 8 to 9 weeks.
So, Takanaka's objective was clear: to decide on a flooring system which wouldn't disrupt other vital work taking place, and, more importantly, a system which offered speed of construction and a high-quality, low-maintenance finished product. There could only be one conclusion. At the heart of the system is a laser transmitter, which is placed in a convenient point within the structure of the building. This sends out the relevant data directly to the screed's onboard computer via 2 receivers mounted on its working head. These signals are relayed back to the operator's console, which automatically controls the level of the head. With the transmitter rotating at 300 revolutions every minute, the head is constantly checked and adjusted at a rate of 5 times a second, far quicker than any human response. The screed itself has twin axles, 4-wheel drive, 4-wheel steer, and 4-wheel crab steer. Its boom can be extended to over 6 meters, and with the ability to travel sideways, the screed can reach even the most awkward areas. Although the system incorporates state-of-the-art laser technology, the method of operation is surprisingly straightforward. Concrete is poured directly onto the area and spread by hand to approximately 25 millimeters above the required level. The head is then lowered until it locks onto the laser signal, and as the boom is slowly retracted, a vibrating beam inside the head compacts the concrete as the plow spreads it to the required level. In one pass, the screed will level and compact approximately 22 square meters of concrete. A computer-controlled topping spreader then applies the required quantity of dry shake topping. The spreader is designed specifically to work alongside the laser screed for optimum efficiency and effect. Once the concrete has stiffened sufficiently, power floating operations can begin. During the first phase, the concrete is worked with highway straight edges and ride-on power floats fitted with rotating pans. Bladed power floats are then used to achieve the optimum smooth, flat finish. As soon as the power floating process is complete, the area can be cured using a spray cure membrane. This hardens the floor and acts as an excellent dust preventer. It also means following trades can gain access to the area far more quickly than with conventional methods. With the laser screed system, it's possible to construct up to 5,000 square meters of flooring per day, 8 times more than with the traditional strip construction method. The concrete is leveled and compacted in just one operation, producing a high-strength, flat and durable floor. With the laser screed system offering such obvious benefits, Takenaka had made one important decision. But there was one even more important decision to make. Snowden Flooring were pioneers of the laser screed flooring system here in the UK, and have maintained their competitive edge by recognizing that with today's highly sophisticated storage and handling systems, the end user requires a level floor slab that can perform under far more stringent conditions and demands than ever before. The Toyota project is just one example of how Snowden's vast knowledge and experience in all aspects of this highly specialized field, from design through to construction, ensures that the end result is delivered precisely to their client's technical specification, timescale, and budget.
We obviously took a lot of research, because concrete floor technology's moved on, to make sure that we picked the right sort of companies to carry out the project. With Snowden's experience and the sort of support that they gave in terms of design, the proof of the pudding's out there, in as much that it is absolutely bang on, the system was right, and the quality of the product is good.